Okay, so welcome everyone to this week's Compiler Architecture meeting. So this week we have a talk from Dr. Natty at the University of Alberta, who's been looking at how to make some of the technology that we have more extensible and consumable by other projects. So I believe she has a presentation that she'll go through, so I'll just turn things over to Dr. Natty.
Okay, perfect. Thanks, Daryl. So hi, everybody. So I'm Sarah. I'm an assistant professor at the University of Alberta. And part of my research is involving looking into configurable software, or what's called software product lines. So when you have to cater to multiple requirements, multiple platforms, have features that are optional that you enable or disable them. And that's how I kind of got into this working with the OMR team. So let me start by, so that today we're going to talk about OMR's design and some of the things, some of the problems we found with it. But what I'm going to start with is basically some of OMR's basic design requirements. So OMR has what we call 3 variability points. So you need to select an architecture, or like build it for a specific architecture, the language, for example, if you're targeting Java or Ruby, and the operating system you're running on. There is also considerations like making sure that any design that you have has good compile time performance. You don't want to wait forever for your code to compile. Has a low memory footprint. So when running that code, the produced code has a low memory footprint. And the runtime performance, obviously. And a main criteria is that the design should be language agnostic. So in the end, OMR is supposed to be supporting multiple languages and extensible for those languages. So, I mean, probably everybody here already knows. So the current implementation mechanism used for supporting this kind of variability is extensible classes through static polymorphism. So you have the different namespaces, you have the same class in every namespace, you have things like the connectors, which are typedef to the different classes in the different namespaces, and then you have your concrete class, your TR, that happens in the TR namespace. So this is the current state of things, and what happened, just to give you a bit of background, is there was the main problem or main pain that people had, which was using self and extensible classes. And so what happened is about 2 years ago, a little less than 2 years, Matthew, who's not with IBM anymore now, but who worked in OMR, he gave a presentation about how OMR worked, and it kind of related to things I know about configurability. I was mainly working with like the Linux kernel with different ifdefs and so on. And so we started talking about how the current implementation mechanism is hard. People don't understand the self usage and so on. And along with now Shaoli and Robert, who we're working with after Matthew left, and the team of students from the U of A, what we tried to do is basically develop tools that help OMR developers understand the variability in their code. So understand what a class looks like, where a function is overridden, and so on. So just to help them navigate this code. And also to decide about maybe what the best design strategy or implementation mechanism to cater for this variability is. So example, exploring static versus dynamic polymorphism. So just to give you some background of the kind of work we've done so far. So the first thing was Samer, who was the master's student working on this project. He built a static analysis tool called OMR Statistics, which basically gave different information about the polymorphism going on, such as where a function is overridden across the different architectures. So a bit of to try to understand where this function is overridden, where it's used, and things like that. And then we moved on to actually investigate whether migrating to dynamic polymorphism is feasible. So one of the options of removing the self problem is to actually use dynamic polymorphism. Now, the main concern there was the performance, but this was never actually empirically evaluated. So we started working towards that. It's a bit of a slow process because you actually have to do a lot of edits in the code and get things to work correctly. So what we did was we converted 5 classes to use dynamic polymorphism. And based on the first class code generator, which is the biggest class, we ran some benchmarks, like very early benchmarks. And these are 2 benchmarks, the day trader benchmark and ODM benchmark. And these experiments are so far only in the based on the code generator class and x86 architecture, but we noticed there was no significant change in either direction. So this is all like the difference in means errors within the confidence interval. So there's really no significant changes either for or against using dynamic polymorphism. So this was kind of good news. Okay, maybe dynamic polymorphism is the solution. But as I got to understand more and more what is happening in OMR and how it works, I realized that dynamic polymorphism only solves part of the current problems and challenges faced in OMR. So yes, it will remove the use of self, but that's about it. It will not solve any of the other problems in the design. And so what I wanted to do at this point, before going ahead and changing like the whole code base or coming up with something new, is to actually understand what are the current problems being faced and what are maybe constraints for any potential redesign of OMR, so that we don't go ahead and do something that is then a disaster or that ends up like, oh no, you didn't think about this or something like that. And the plan is, after like eliciting these problems and constraints, is to explore both the literature related to configurable software and software product lines, and look at also similar implementations in the open source community, and try to come up with, here are 2 to 3 recommendations that either satisfy all your requirements or we lose this requirement, and to actually have perhaps a student that can try to do this migration and see how it affects things. So what I did is I did an interview study with some of the current developers who contribute to or use OMR, particularly 6 developers. They include recent members, but the majority actually worked with OMR for at least 2 years. So a lot of them have been there for a while, have even witnessed the change to the new extensible classes and the new open sourcing that happened in the last 2 years. And the goal is to identify the problems with the current design, as well as any constraints for any future solution. So what I want to do in this presentation is I'm going to present these problems that I've identified. And my goal is I want to get feedback about them, elaboration, perhaps I misunderstood something, or that there's actually something that didn't come up that some people are interested in, and also to get a priority list of these requirements. So obviously, there's never going to be a perfect solution that satisfies everything. So we need to understand what is a priority and what is maybe something that would be nice to have, but not essential at this point. So before I proceed, some disclaimers. I'm not an OMR developer, so some of you probably understand the code way better than I do. And the information that I have is not my own opinion, it's the opinions of participants. Some of the requirements are my interpretations, trying to put together like kind of the complaints that I heard and putting them in a requirement form. And at this point, we don't have the solution yet. The point is, after coming up with this prioritized list of requirements, is to go and explore the solution. And by the way, I'm happy to take questions in the middle if you want to interrupt at any point, so don't feel like you have to wait till the end. Okay. So before I go into the problems, I'll start on a more positive note. So some of the comments, the positive comments about the current design of OMR that emerged in the interviews. First, going open source is great. So that was like one quote. So that's a positive thing because it forced that the design, now other people use it, that the quality of the code is getting higher and so on. People now like that the namespaces provide this logical separation of concerns. So you know that this code belongs to x86 while this belongs to power, for example. So it's a clearer separation of concern. Now, one of the things is the current static polymorphism, so with extensible classes, because the way it works, you can actually just decide to introduce a function in any point in the hierarchy without necessarily going and putting it in the base OMR class. So that, even though it's not that intuitive, it allows avoiding the pollution of the OMR class. Another thing that came out is that people are excited or hopeful about the migration of this using CMake as the build system, because it will make some things simpler, like configuring an ID and so on, as I will talk about in a minute. Okay, so I'll move now to the problems with the current design, and I kind of grouped them and sorted them according to how many people talked about them, so they go from most common to least common kind of thing. So the first main problem right now is really the code navigation and comprehension, and this comes in several parts. So the first thing is, as a newcomer, it is actually kind of hard to understand what OMR is exactly and how do I get started with it, because it's not a standalone product. You're not building something that you can run right away. You're not even building a library that you're going to either statically or dynamically link in. So it's hard to understand, like, where do you get started with it? And due to that, then building it is not always straightforward, because you have to know where to go change things, and that you have to build it for a specific architecture, a specific language, and after you even add those extensions in. And another thing is the extensibility boundaries are not that well defined. So so even the fact that there's now two ways that you can extend OMR. So there's the JIT builder route, where it's more of an API on top of OMR to make things easier to extend. And actually, as somebody kind of a newcomer to OMR, that wasn't even clear to me that JIT builder is an alternative route to go. So that's one option you have, and then the other option is to directly extend the extensible classes similar to what OpenJ9 does. And then you have to figure out that there's some extension points that have default implementations, some don't, and you need to understand where you want to extend things. So as a newcomer, this is really hard to figure out all of those things. The other thing in terms of code comprehension is just understanding what does a given class look like on, let's say, Power or x86 or something like that. So you need to understand which functions are defined in that class for that platform, what are they overriding, and so on. And right now, it's actually hard to get kind of a static picture of what this class looks like. And this is mainly because of how the build system works and how extensible classes, it is actually hard to navigate the code, especially in an IDE, if you want to do things like look up a function declaration or find usages or things like that are supported toolings in an IDE. You need to find a way to configure your IDE for your particular language or architecture. What I understand is now people go and say, let's say I'm working on Z or Power, I go get all the include paths that are just for Z and Power, have to manually go plug them in my IDE, and then it supports it. It's not easy to flip back and forth and say, okay, now show me what it looks like on x86, and then go back to Power and things like that. So navigation is currently one of the issues. There is also the fact that in some cases the code is scattered in certain parts of OMR. So if you're not really familiar, like intimately familiar with the code base, it might be confusing. So some examples is like managing code caches. There's two classes that you have to go look at what they're both doing to understand how that's done. Queries, where you look at whether some feature is supported on specific platforms or not, or basically these queries for feature supports that are there. They're scattered across three classes, and it's not, from what I understand, it's not even consistent, like which queries go where. So that again makes it hard for somebody to understand what the code looks like or where's functionality implemented. Now the famous self, which is, I guess, the main complaint that a lot of, actually, I think everybody who I talked to had, is the use of self is unintuitive in the sense that if you're used to polymorphism in C++, you're used to virtual functions, for example, it's not natural to you to use self. Now, people say once they got used to it, then it's okay, but it is something that is strange once you start using it. And because of the fact that you have to use self, it's kind of frustrating because even when it's not needed, even when you're not really using a function that's being overridden or where you need to use self to get the right behavior, you still need to use it to avoid getting the linter complaining and your pull request or your build failing. Another side effect of self is because with self you cannot put function definitions inside your header files. So this forces the use of this extra inlines.hpp file for every class. And this adds another layer of complexity. People have to understand why is this being used, and also that you need to include it in the right place to get it to work correctly. And then related to that is also the idea of connectors. I kind of believe I might have misunderstood this point if somebody wants to clarify it. I believe it's mainly using the TR namespace, but because if you use static functions, you may forget to actually use the connectors, and that may lead to wrong behavior. So if you're on x86 and you forget to use the right connector and use a static function, you might end up getting the wrong function instead of getting the specialization of, like, let's say i386 or AMD64. So yeah, so it is also an added layer of complexity, and it may be error prone if you don't use the right one. So putting all these kind of together, and also from feedback I got, is that the first requirement is that the simplicity and usability should be top priority. So we should think of when a newcomer comes in and tries to use this code, that it is clear where extension points are, avoid maybe new kind of constructs like self and connectors that are not that intuitive to people. And so, yeah, the new design should be designed for simplicity and usability, especially if you're in an open source community where you have contributors that you want to encourage to be able to be part of this. The second problem is this code spread that happens both within OMR and across the repositories with OpenJ9 and OMR. So because of this hierarchy and the fact that you have connectors and the TR namespace and so on, if you make a significant change to a class, it means now you have to edit several files. So you have to look at the TR namespace, the OMR namespace, the architecture specialization. So there's lots of places to edit. Now, personally, I'm not sure if this, like, if you have any sort of hierarchy, this might always be the case, but that's one of the things that came up. And now the worst part is that because of this, you might miss non-obvious edits. So for example, if you change a constructor in J9, it means you need to change the TR version as well in OMR. Or that if you add code that is J9 specific, you still need an update in OMR, and actually it may end up in these if-def J9s, which are making the code harder to read and making maintenance harder. So you need to figure out that you need to not only edit the code you're interested in J9, you also need to edit in OMR as well. And because of this, it might lead to inconsistencies. So the fact that it's actually the code is spread across 2 repositories is problematic in the sense that for things like in enums, because you don't know what the downstream project depends on. So if you're changing, let's say, enums in OMR, you need to be very careful about the order because OpenJ9 depends on a specific order of how these enums are declared. So you might break something without even knowing because it's downstream in a completely different repository. what I understood also is that the build system between those two repositories is inconsistent. So even the build flags to indicate architectures are not the same. Things like CXX flags are not respected in OpenJ9. So it's not like you can configure your build for OMR and have it trickle down to OpenJ9, have all these build options trickle down. And again, because of the fact that you change things in OMR and don't know about the dependencies in the downstream projects, if OpenJ9 has any assumptions about things like table sizes and you change them in OMR, you may cause problems that will not even end up in build breakage, but might end up reading incorrect data, for example. And because of all how this works, is it ends up also in process slowdowns or process additional burdens on the process itself. So right now, if you need to make a change in OpenJ9, it often means that you need to touch the OMR code. So then you need to go open the PR in OMR and wait for it to get accepted before getting on with your work. So that's kind of a process hurdle there. And also the fact that because of this, even if I'm not a core OMR developer, I may end up needing to contribute to it. So it's not really kind of a good separation of concerns in terms of developers editing things. So based on this, what I think one of the requirements should be is that there should be more streamlined consistency checks and editing capabilities where I can edit in one place and make sure that it trickles down to all the right places. Now, how this is done is still open for discussion. But I think the fact that you have to go edit like 3 or 4 different places is error prone. So somehow the design should take that into account. Now, a more concrete problem in terms of right now extension mechanisms or being able to extend things for different architectures is that there is no current extension mechanism for enums, unions, and tables. So the extension mechanism right now is basically this using macros and includes for things like enums, and that you need to go back to OMR to add things. So the example here in the slide, I don't know if I can get my mouse to move. No. Okay. Is the opcodes where first you have a header file that has these enumerations that's included in the enum definition, and the order that these enums appear need to be the same order that in a completely different file that has the properties of these opcodes. It has to be in the same order. So these things need to be consistent, and you need to go and figure out that you need to edit these, I think, 2 or 3 different places and make sure that the order is consistent. There is currently no way that you can just add an extra property there or like extend the enum without going through this include magic with the macros. So a new design should have a mechanism for extending enums and unions, and when talking with some of the developers, it might be that you need to not only support adding new fields, but also maybe changing the type of a given field. So you might, in your union or something, have a different type, or in the enum. So it should be able to support these, both adding a new field or changing the type of a field. Sorry, in the tables, actually changing the type of a field, not in the enum. Now, the fourth problem is the constructor problem. And this is more of just the fact that based on how things are designed, any constructor of a given class has to be a superset of all the other architectures. And this leads to extra or unneeded parameters for some architectures. So you might have a long parameter list for the constructor, while for your given architecture, you don't really need all these parameters. So that causes these to look, I guess, more also in terms of just code comprehension. If you're an architecture that doesn't need this, this is problematic. So as a requirement, probably want to be able to have some varying constructors across the architectures or languages, such that you only need to specify the things you need for that given architecture. Another problem that came up during the discussion, which isn't really specific to the design, but more of the process, is that right now, when there's a new change to the code generator, it's delivered kind of pieces at a time, and that through different pull requests, and that may lead to inconsistent or divergent behavior. So as an example, if you need to add an operation where you need to know whether you're on a 32-bit or 64-bit architecture, if you start by actually doing this operation on an architecture where you don't need that piece of information, then you will ignore it, and your function will not even have that as a parameter or part of your query. On the next architecture, then, when you come to implement that same operation where you need it, then you need to change things to incorporate that information. And sometimes if people don't go back and change what's there, they just add a new function for that. And so things start becoming maybe there's duplicate parts, or they're inconsistent in terms of what needs to be there. I did not put this as a requirement because I think that's more of a process change rather than a design change per se. So I didn't think this is something that would show up as a requirement, but we can discuss this at the end as well. And the next problem is OMR's legacy baggage, basically, that there is too much Javaism inside the code. The intermediate language was designed for Java, so a lot of the OMR code is actually not really generic, which means that as new things start to be needed for other languages and other clients, things get added to the OMR namespace, and then it's like this kitchen sink problem where you're just adding things without thinking about what is the generic meaning for all the clients, or how can this be more general and extensible. So as a fifth requirement, the new design must be based on language-independent constructs. Now, this is something that needs internal team discussions. It's not something that's really just related to the implementation strategy, because these generic functions or generic extension points need to be defined for to be language independent. So that was the problem list, but and kind of requirements based on it. But during the discussions, there were also additional requirements or constraints, really, that for any potential solution. So for example, right now, all the variability decisions, so you know, like at compile time, which architecture you're building for, which language, which operating system. So everything can be done at compile time. But in the future, if with supporting things like JIT as a service, there might be the need for some dynamic decisions. Now, whether this is that you really just have like the three architectures pre-built and you use those and you just query it, or if there's something that needs to be decided at runtime. But this is a possibility down the line that would be good to think about in case the new design can already accommodate that. Another thing is that what I understand is previously a template solution was explored, and one of the problems with that is that it resulted in strongly connected components where to compile one class you needed to pull in a lot of other components that are tightly connected to it because of how templates work. And so this is one thing that you want to avoid in a new design. Now, more of a technical constraint is that in terms of C++ features, we cannot use something that is not supported by the lowest common denominator of C++ versions. Not all architectures support the same C++ version. So that's something that needs to be taken into account, not to use advanced language features. Another requirement is, or maybe a wish list, is kind of maybe to enable finer control over extension points. So for example, you might want to say that this function is only exposed to OMR classes. An external client does not need to do anything with this, while this is actually an extension point for just the Java client or the Java language, while this one is for Ruby, for example. Or you could say this is an extension point for anybody. So you might want to be able to control this granularity level. And another thing is the design should make it easy that, so let's say I've extended OMR at version 2 and started doing things, and now OMR has new updates, and I need to incorporate those updates in. The design should be made in a way that it does not really break all my extensions, so that it's easy for me as a consumer or a client of OMR to be able to integrate those new updates. And as a final requirement is to keep testability in mind. So the design should enable easier testing without needing to mock the whole compiler to test any single part of it. So this is my last slide here in terms of thoughts for possible solutions. So I did ask everybody I talked to, is like, what do you think would be a good solution or a better design than what you have? And I mean, most people actually didn't really know what a better design would be. They knew what is causing them problems or pain, but not really how to make it a lot better. There were some ideas like having more of a code generation framework. So like having some metadata where you could describe certain things and then have the code generated for you based on what architecture you want and so on. There are two factors here that need to be taken into account. Is that you need to consider or be able to also debug a problem. So whenever an error happens, it's going to be in the code that's generated. You need to be able to debug this back to whatever domain-specific language or the metadata that you have. Versioning also, so you'll have now versions of the metadata, and then the code that's generated, you need to know which version it came from and so on. And one of the things that we'll probably start with, because something like LLVM and Clang share many of the same, I guess, design requirements here. So looking at them to see how maybe they handle some of those issues could be used as a source of inspiration. And I'll end on the slide, which has the laundry list of all the requirements from the presentation, and we could use it to start the discussion.
Thanks, Sarah. I think that was a fairly good consolidation of your discussions that you had with the developers. So I think there's a lot of good good points in here. I guess one thing that one of the requirements that you'd mentioned late was the need for, or the potential need for adding more dynamicism to the configuration. So right now, you're right. We do assume that things can be configured statically, and which is sort of why static polymorphism works. But as we are starting to move some of this code into projects in the cloud, which may need more dynamic configuration, I think it makes sense for us to sort of factor that into anything that we are thinking about now, rather than add it on as an afterthought. So, you know, if that's the way that we want to go, then I think we need to factor in dynamicism. Is such a word? Again. Dynamism.
So what would be, just to make it concrete, an example of a dynamic decision? Is it that the platform is unknown, right? Or
well, for example, if you want to have one compiler that can generate code for multiple backends, right? So I want to be able to cross-compile x86, and I want to be able to cross-compile to Power on the same compiler. Right now, the way that the code is structured, it doesn't really work that way, because the assumption is you're going to have one code generator for a compiler. So if you want to, for example, in a service model, if you're going to be able to generate multiple code for multiple targets, you're going to need to make that more dynamic.
Mm-hmm.
I guess even different language front ends would.
Because I mean, there is the what I mentioned, like the naive solution that you actually have these all like pre-built, right? And you just query the right one. If you get something like you want to generate this code for x86, you go to the one that was built to x86. It's
right.
more of the naive solution here, right?
Yeah. Well, when we sort of kicked that can down the road a few years ago, the way that we had said that if somebody does want to do a cross-compilation solution, that's how you would do it. But I guess the question is whether or not that is the cleanest way of doing it.
Mm-hmm.
Probably not. So.
And this generated code will not run on the current platform you're on, right? You're returning this like as a service, so somebody else is going to take it and run it, right?
If the host and target architectures are different, then no.
Okay. Yeah, that's it. Okay.
Well, I don't think that the current state of the code base even really accepts the fact that you may build the code generator for one backend on a different platform, right? There's the support for that.
100% true. ARM, you can build it.
ARM you can, but I'm not so sure if the other code generators will react well.
The legacy product from which this came used to be.
I know it used to be able to. Whether it still can, I think, is.
No, there's work that.
It probably can't, but it's not a full redesign required to get there.
No.
Although finding the places where it has lost its way would be non-trivial. Yeah, I mean, a little bit of context here, which I guess isn't in your presentation. I'm not sure if it came out in some of the developer conversations, but I guess it can provide a little bit of context for how we ended up where we are on this set of problems and solutions. So the OMR code base used to be shared by a larger number of compiler projects, on the order of 8 different compiler projects. OpenJ9 was one of those, and was the original one that the code base was developed for. But there'd been about on the order of a decade worth of development to create those other compiler projects at the same time as the J9 JIT compiler. And by the time we got around to starting the OMR project, it was the case that we had a lot of conflicting and sometimes very strangely different ways to use things that looked like they should be very similar across all of those projects. So we had a lot of sort of very weird dependencies tied together through our code base that was hard for any one person to understand. It worked very well for each individual project because they each individually understood how things worked. But if you started looking across the different projects, it became hard to have a sort of unified, we use the term conceptual integrity, across all of those projects. And so when we started down the path of creating OMR, one of the challenges that we had was that we had all of these different projects, and not all of them wanted to be open sourced along with OMR. In fact, none of them originally wanted to be open sourced. Even J9 was not slated to be open sourced originally. And so we had to find a way to marry this open sourced OMR generic toolkit notion with multiple different consumers using the classes all in different ways. And so that kind of led to, I guess it's requirement 9, right? Enable finer control over extension points, which originated from the observation that the current extension mechanism lets you override just about anything. That was actually by design at the time because we needed the ability to do that, or else we couldn't have any notion of a clean OMR implementation because they were all so different.
So I think this is, and I mean, I did get some of that history in the conversations, but wouldn't this also be related to requirement 5? Is because of how you took the J9 component, that's kind of what you used for OMR and had to put in the other stuff on top of it. It became this lots of Javaism in there that there wasn't really thinking about what this means generally for any language or something like that.
Well, I would say that we're on a path for that. We started from a place where everything was Java-centric, right? So in the end, just to finish my earlier story, so in the end, we ended up divorcing from, not the right term, but we
court settlement with?
We separated amicably from most of the other compiler projects, and so we were able to return the code base to a point where it was again like the Java JVM JIT that we started from, but as you know, that's a very Java-centric kind of notion, and so we then had to proceed on the refactoring to create the OMR project in the first place. And I guess one of the pieces that we didn't make as much progress on yet as we would have liked is making the OMR project a little bit more generic than it currently is, or than it started. I think we've moved along that path from where we started, but we haven't gotten, as you've noted, or as people have noted, we're nowhere near where we need to be on that journey.
Yeah. I guess one other design requirement that isn't called out in this set of 11, which may be less of a concern directly to OMR, but as a committer on OpenJ9 that consumes OMR, the compile time, like the amount of the performance of the code that's compiled to make the JIT, so namely how fast the JIT compiler runs and the amount of memory that it consumes is important when this compiler is embedded in a runtime system. So changes in the inheritance models and that kind of thing, if they have significant impacts on those metrics, may make consuming some of those downstream more difficult.
Yeah, so this was... Sorry, go ahead.
No, go on.
Okay. Yeah, so I think this would go back to this. So I take those as kind of the basic design requirements, that the compile time performance and the memory footprint and runtime performance. So those, and I believe this is also what drove the current design, like with the static polymorphism, is things like the runtime performance was something people were worried about. So yeah, so definitely that would be something that's taken into account.
I guess that just given some of the requirements that have been raised, I think one of the things that may be a limiting factor as well is not just the C++ compiler version, but just the capabilities of C++ and its preprocessor for solving some of these problems, which I think might be why some have suggested a more metadata approach to this, in that you may not be able to get C++ to solve all these problems on its own. It may need some other tooling help in order to achieve that.
I mean, I think the crux of it is that we're essentially trying to implement mix-ins in a language that doesn't really support mix-ins very cleanly. Right?
Yep.
That's what we're trying to do. And that's where we ended up with the static polymorphism approach, which actually was chosen at the time that we had 7 different compilers building out of it, and wasn't revised after we got to a simpler world. But so I'm perfectly willing to believe that we're at a different point in that design spectrum, and that we have the ability to do this differently and better than we did it, or that when we originally made those decisions, certainly.
Anecdotally, I remember early on when I was talking with Mark, Mark mentioned that one of the outcomes of this whole refactoring exercise is that we'll have a really good idea of what language, what a compiler implementation language should look like. So
And as language people, we should be designing that language. Maybe that's where the metadata thinking process ends. We design Rust or something.
We'll design it and then we'll implement it in templates in a way that's going to be almost impossible.
So what about so like requirement 9, the finer control over extension points. So I guess I want to like kind of prioritize these requirements a bit, or are these all like must-haves?
So we're all staring at them right now.
You know, take your time.
I mean, I would still put requirement 1 close to the top. It's kind of hard to argue against that.
I'd say 3 is pretty important too, because
3?
at least in like on my side right now with AOT, it's kind of annoying to have to go to OMR to update the reload kind, only to use it in J9. It's sort of be nice if we could have an extension point there so that the things that only J9 cares about can be in J9. I think we sort of
for the record, nobody really applied a refactoring
AOT
implementation, so that's.
I know.
Because there are a couple of enums that are
the optimizer, I guess, right?
Yeah.
Although the opcodes is the one that, if you'd asked me, I would have pointed out the opcodes as being the prime example of that, but that was one of the negative examples in the presentation. So.
Well, I mean the optimization enum is one that has actually worked.
Yeah.
Sorry, which one is that?
The optimizations enum.
Okay.
Right. So there are open J9 specific optimizations, and they are added to that optimization enum. And the initialization code is factored in such a way that if you have a Open J9 specific opt, it only has to be initialized in Open J9. The only reason that there's still lots of pollution into OMR is that the options processing doesn't handle that extensibility properly yet.
Right. And so that's basically a tribute to work that Luke and Shelley did to make that work, right? Yeah. So, it's an indication of an area where we would need to invest areas that we need to invest further in to achieve the same kinds of benefits.
Mm-hmm. I think the opcodes, though, is because the properties and the opcodes have to be ordered the same way. So I don't know if it's really the problem of setting in on the sort of union, more maybe the tooling can help, or having some kind of a meta language where you can describe your opcodes and your properties and then generate. I don't know what the solution is, but I think the problem is the interaction between the opcode, the list of opcodes, and the list of.
So you're saying there's 2 types of problems here. The first is the fact that the opcodes and their properties are separated, right? So that means you need to keep consistency, and then they're decoupled. And the second is that then for the specializations in J9, you still need to go and put them back in OMR, and that's a different type of problem.
Yeah, I don't know about the AOT problem. Like what?
So I mean, you could do a similar thing in terms of the fact that the reload kind, the relocation record, and the binary templates are all very, very, they're basically the same. They're describing the same concept. So they could be auto-generated except for the applied relocation and some of the other stuff in there. But at least I don't know if
they have to be auto-generated, but I think, certainly the problem with the AOT infrastructure is that there's a bunch of it that just has to live in AOT because the code generators live in AOT, and that's the code that's generating the relocation. So there's a kind of a connectedness problem here that you want the code generators to be in OMR. You've done something, I know Daryl's done some work to try to genericize the notion of adding a relocation when the code generator is operating, I believe. But fundamental problem is that the relocation infrastructure needs to live in OMR so that the code generator can use it. But then the implementation of the relocations is all Java specific, so it lives in OpenJ9, which complicates. We don't want to sync the Java implementations into OMR. That's not the right solution. But right now the problem is that there is a bunch of Java stuff still, Java specific stuff still in
Although,
OMR.
I mean, some of it has been refactored properly, like the whole add metadata for code for instruction for code. That's yeah, that one actually could just all go away. That
right, right.
I think the only ones that might remain are the before binary encoding ones.
So, I mean, if one prioritization that I would put on this is anything that makes that requires connected PRs in OMR and OpenJ9 is clearly a bad problem, right? And it's something that we suffer from quite a lot, right? There's a lot of build breaks that happen in OpenJ9 and sometimes in OMR because of that problem, right? So anything that prioritizes making that problem simpler is, I think, a good thing.
Yeah, the only thing there is, like, you will still need to have separate repositories, right? So,
of course, yes, definitely.
So then the only thing I can think of is tooling that would check consistency for you or something like that, because as long as they're separate, it will have to, like, follow the same process here, right?
Well, but we have a lot of code where it's the definitions of things, as we kind of pointed out in the conversation, things are coupled between OMR and OpenJ9. You can't change something in OpenJ9 without changing something in OMR.
Oh, so you're talking just about the coupling part.
The more that we can fix that problem, I think, the better. If there's one requirement on the list that I would deprioritize, in my opinion, which for whatever that's worth, would probably be requirement 6, because I don't. The JIT as a service people may differ on this point with me, because they're the ones who are likely to struggle with this one. But my general opinion is that we should just build a different compiler and then have a meta process managing that problem. At least we consciously made that decision. Daryl called it kicking the can down the road. We consciously made the decision at one point that certain things were going to be static, and I think that decision back then probably has made it harder to go back and make those things dynamic, but I'm not sure I see a justification for making them dynamic in a single implementation of the compiler right now. So requirement 6 would be kind of low on my list, but many of the other ones look very important to me. It's hard to prioritize them.
There's it's a concern in terms of requirement 8, which is people are going to want to use like C++ features. I mean, what is the lowest common denominator that we force, right?
Well, that comes down to what platforms do you want to support, which any mature language community usually gets stuck in that problem. Right? That they don't want to throw their users under the bus, so they maintain an older support statement, and then that's what kind of forces that decision point on us, unfortunately. And then the platform's not providing modern C++ support in older operating system levels is the other piece of that complicates it for us. So if we can solve one or both of those problems, then great. The first one I don't think is solvable. The second one may be relievable, but probably not solvable, right, until client takes over the world. So I think we probably just have to suffer with that one for a while, and we'll probably never be anywhere near the cusp of C++ development, but that may not be an awful thing either.
Yeah, well, I know a lot of people will be pointing at LLVM and the use of C++ in LLVM. However, if you have ever had the joy of trying to get that project to build, especially with C, you have not experienced a level of pain equivalent to that, because like they maintain lists of known good GCC versions. There are many versions that don't build the code base, and they regularly factor in new C++ language features but the implementations of those are not generally consistent at the point where they start appearing in the code base, and it causes a lot of pain for some people. Also, they do a lot of the metadata table generation kind of stuff. They even have TableGen, which is a Python script that does this. It has its nice properties. However, if you ever actually have to go and modify some stuff with TableGen, you'll rapidly discover that it is a DSL full of single letter abbreviations for things, and where lowercase l and capital L mean different things, and you have to go and back solve exactly what this set of esoteric flags actually means. So while you don't have to have coupled implementations, you have a sufficiently terse and abbreviated form that was convenient for the person who wrote it, but that is not easy to figure out after the fact. So
debugging generated code is rarely a treat either.
Yeah. So I think a happy medium may need to be reached on that point. Don't know that their extremist view on that is quite.
Yeah. Well, I mean, we've started using, we have used generation for some of these things, like the FT ops or whatever that thing's called.
Well, I mean, the x86 code generator is built using that now, right? There's macro expansions into particular lists. Define everything in one row and then pick the parts that you want for each of the different things so that it can generate the names and the enum and the properties and the.
Actually, our helper stuff used to be probably not right to call that a generator solution. Stranger than that. Okay. At least some people had some good things to say. That was nice to see.
It was actually not as like, I thought it would be worse than everybody complaining, but it was like more of, yeah, this is a pain, but we've learned to live with it, and like it wasn't as bad. So I'm just here, it's because I'm summarizing all the problems, so it sounds pretty negative, but it wasn't.
Yeah, it was a different experience when we were going through it and initially creating it in the first place.
Well, we did iteratively as well.
Yeah,
right?
I know.
So we went through
which wasn't popular. Let me tell you.
It didn't help that the actual static inheritance mechanism changed at least once in that process while the code base was in flux.
I know. I'm not saying. No, anyway. Let's not bring up all those memories. Only for my sanity. General mental well-being.
For that one.
Does anybody have any comments on the other comments on the requirements?
What about requirement 4? I mean, I see it would be nice to have the minimum, like the minimum required for every architecture. And if we go down the code generation route, then that is possible. But with things like if it's something depending on inheritance, it's either going to be that it's the superset or it's going to get ugly into like different constructors for different languages.
Well, I mean, we have a solution for that. But again, it's not the most usable solution.
There are no clean answers. That's the problem.
Yeah.
Okay.
I think we actually have that documented in a design. Or maybe it didn't make it in the open yet. We did some experimentation with constructors, and basically what you do is you pass an extensible structure up. You probably can't hear some of the groans in the room here, but it'll work.
Var args without the var args.
Yeah, there are ways of making it cleaner, like easier to use.
Yeah.
It's like you pass the object along, so you write a setter on the struct for every field, and then everybody just does like create one of these that, then you construct. Or you can do it the other way around. You can separate construction from initialization if you really feel keen. But this is just one thing where the C++ notation just doesn't quite work. There are no clean solutions to it, unfortunately, if you're really trying to do mix-ins, which in a bunch of places we are.
And then in terms of requirement 2, which was related to this idea of that you have things in OMR that are in J9 that are tightly coupled to OMR, and that might lead to inconsistencies or the pain of going and editing 2 places. And what I understand, like from the discussion we had like a few minutes ago, it's mainly if the design can avoid the tight coupling in the first hand to avoid this problem. So it's not really the consistency checks, but more that if the design itself can support more loose coupling between those 2.
And yes, but that's probably more my wishful thinking than a pragmatic solution.
I'm just understanding what's
there's a lot of things I think that we'd have to fix in order to get to completely eliminating the coupling between OMR and OpenJ9 would be a lot of work, which is why it hasn't been done yet. We are moving gradually towards it, but gradually is probably the most appropriate word in that sense.
And
in the meantime, things like consistency checks and other things would help mitigate some of the pain of working in that coupled environment, I guess.
I had one note. It's more a typo on the previous slide, which mentioned that if you, just to clarify in case it gets out, if you change the constructor on J9, you change the TR constructor also in J9, not in OMR. I think the slide said in OMR.
I think I know which slide you're talking about. Yeah.
So I mean, it's
It can be an OMR too, though.
No, it can be, but I think this is specifically if you we always refer to J9 compilation, but you change the constructor in J9 compilation, and the build will fail because you need to do the appropriate.
Oh yeah. I see what you mean.
But it wasn't in OMR. It was just that if you change J9, you also have to change the TR.
So that's not referring to the problem where you have to pass a J9 specific constructor.
No. This is literally one of the points mentioned was changing it in OMR, and it wasn't OMR. Light pane.
Okay. All right. Okay. I understand.
Yeah, I can fix the typo before sharing the slides with Daryl.
How important is the requirement 9 where you enable finer control over extension?
Speak louder.
Sorry?
Speak louder.
Oh, I just wanted to discuss requirement 9 where it says enable finer control over extension points. How do people feel like is that important? Because I mean we have a number of requirements, and the more requirements we have, I think when Sarah and her students do the research or the literature search on solutions, we'll come up with things that might be useful to the team.
I think it's going to be easier to define a compiler API if we actually did have, if we could specify what the extension points are.
Okay.
Because right now it's very open-ended.
We now have, if you'll forgive the word in this use, we have the luxury of applying requirement 9, which we didn't in the past. In fact, we had to go the other direction because of the design point that we were forced into at that time. Now I think we have that luxury, and I think we should exploit it because, as you say, I think it simplifies how consumers of the project will understand what they need to do in order to modify the compiler, and modify it in ways that we can anticipate, which means it's easier for us to devise testing around. Not that we've done a great job of this, but if we know where the extension points are, it's easier for us to understand how testing should be done at the OMR project layer. If you can change anything, then how do you test that?
Yeah.
But this is not about also changing. Okay, so there's 2 things here. One is make the extension points clear, and that's definitely something that needs to be defined because otherwise people don't know what to extend and testing is hard. But there's also whether you want a granularity control to say that this is an extension point for only within OMR. This is for any consumer. This is only for the J9 ones.
So
I don't know if that's something required or that you can see use cases for, or if it's just this is extra stuff that makes our life harder and that's it.
you're suggesting that maybe that there are places where we want to be able to enable extension, we'll call it extension, but whatever overriding of behavior across architectures within the OMR project, but we don't want language projects above OMR to be able to leverage those same extension points.
Exactly, because right now, once you have a function you can override anywhere, right? Within OMR or as a consumer.
I think C++, yes.
And so in terms of logically, are there things that you don't want to, that you want to open up for anybody, or only say this is consumer, this is internal, or even if you want, but then if you mark it for specific consumers, I think that makes it no longer language agnostic. Or like you need to know which ones, and then you're making a lot of customizations. Maybe that's not a good thing.
So just a clarification, I think also, let's say in the future we define an API for OMR compiler. I think the requirement here is saying maybe some API now I only want to make available to one consumer versus the other consumer. Is this a requirement that we foresee will be useful in near to medium future?
If we're going to do stuff like that, I think we should just devise different classes, right? So you'd have one class that's for being extended up the chain, and the implementation would be hidden behind. It's kind of like the change we just made to JIT Builder in a way, right? To hide, like we kind of had that concern in JIT Builder too, where there's a bunch of public API in the implementation classes that we didn't want clients to use.
Mm-hmm.
And so we pulled it into separate classes in a strange way, but I'm not saying we should do that in the OMR compiler, but that problem is essentially the same problem.
So that's a uniform exposure to all of the consumer projects versus do you want to treat one?
Yeah, no, I get it. My suggestion would be that we just have certain classes that are private, not extensible, and that's where we not extensible outside of OMR in some way. It would be better to say, like, they may have a public API, but you tell people these classes are not to be used outside of OMR. The extension point is this class over here, which is extended up. I know you can't protect it with C++, but
well, that could be a linter rule, right?
Sorry?
That could be a linter rule, couldn't it? If you extend a class,
yes, it could be. Yeah. So the original extension mechanism, I guess, was designed for extension by language, and then we later added architecture into it because it kind of folded into this. It seemed like it was solving the same kinds of problems, and so using the same mechanism to deal with architecture specialization and language specialization seemed like a reasonable fit. But we don't have to do it that way, right? Like we could, in principle anyway, retreat to you only extend by language, and we do architecture specialization differently, right? Like originally we would have smurfed all the file names and done all of that in one, like the CodeGen directory would just have.
If you did go back to that, you would get rid of the connectors then.
Right.
Connectors are only needed because of the architecture.
Which would be a nice side effect, I think.
But where would you do the architecture specializations then?
You just do them directly, and like you wouldn't have OMR : x86 : code generator that would get folded into an OMR code generator connector base or whatever connector. I forgot the name of the thing. You would just have an OMR : x86 : code generator, which would extend OMR : code generator, and then it would be propagated up through the language interface. It would just be extensible by itself. You would expose OMR an x86 code generator as a valid class for being extended.
But then that means that in the language, I need to know that I'm extending x86 versus ARM.
Correct. Well,
because my understanding is the connector avoids that, is that you could write more generic code in the language.
It would change the way you mix stuff in, yes. So I guess one question is whether or not you can do that. But the theory, I guess the question is, do you right now our solution intermingles common architecture, common architecture, common architecture when you mix across different projects. Another way you might be able to order that, and again, I don't know if it's possible or not. I have to think through this a bit more because I know we settled on this solution for a reason. But another way to do that would be you have common, 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 and then architecture, 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 and they extend at that level. I'm not explaining this very well. You have a common class which is assembled from the different project extensions of the common class, and then an x86 code generator extends that rather than.
I remember we thought about
rather than intermingling it.
Why we didn't go that way.
Yeah, I was trying to remember while I was speaking. I know we did it for a reason, but I can't remember what it was off the top of my head now. But it's that intermingling that makes the constructor problem too.
Yeah.
So anyway.
Okay, so if I try to summarize this for requirement 9, it seems that the priority for requirement 9 is making the API clear. As a consumer, what are my extension points? The fact that I want to specify that I'm exposing this only to consumer X, that's maybe an extra thing, but not like a hard requirement. Is that safe to say?
Personally, I would agree with that, yes.
If we go back to requirement 6, I think Mark was saying that it's not a very feasible solution to go to dynamic decisions, or did I get that wrong?
I wouldn't characterize it as not being feasible. It's just it's a solution I don't think we currently need. But again, I'm not the one in the depths of JIT as a service implementation right now, so I might be convinced otherwise. But the design point that we settled on originally was to keep those decisions static, and you would just build 2 different compilers. And if you needed to have a scenario where you needed to be able to generate code for one or the other, you would just have to have those 2 compilers active. Like you'd activate them in 2 separate processes, and one user would communicate with one of the compilers, and the other user would communicate with the other one. Managing the dynamism between having a single process that can act as one or the other, I think that's actually more complexity than it's worth. Right? I would rather have a compiler that's designated for compiling Java code, one that's designated for compiling Ruby code, on x86, and if a different one, if you want it for Power or for whatever, or ARM or whatever. I think the complexity of having a compiler that could generate both Java, x86, and Java on ARM, I'm not sure that's worth it. Right? The complexity of enabling that in the code base. Plus, given, and on top of that, there's the sort of feasibility, like the issue that there'd be a lot of work to make that happen right now.
Oh, and the overhead of doing that, right? Like,
yeah,
all of those runtime
you're going to add those runtime checks into the compile time
and memory footprint and stuff, right? Which the compiler doesn't have at the moment. And
at the time we did that. That's how GCC did their cross compilation as well. Because one process spawned other processes that are specialized for that architecture.
So, Sarah, what are your next steps with this work?
So the first next step is hiring a student for this. So I haven't had a lot of luck so far, but once I have that student, the next steps is to basically explore all the different variability implementation strategies out there. So there's a lot in the literature that I know about, but I haven't sat down and thought how this would really fit in. Looking at LLVM, even though things like its tables and DSL might not be that usable, but at least ideas on how they do it and see what might be applicable. We could just make a more usable DSL there. So it's trying to come up with at least a couple of options and thinking about those and deciding on one option that seems the most promising, and then we can try to take pieces and see how they would, how we could apply that, like migrate them to that new design. And obviously, it would all like brainstorming with Shaoli and Rob about this in the meantime. Before actually going in, like when we start implementing or trying to do a migration, it should be after careful thought about all these requirements onto the strategy.
Okay.
And just to, there was a comment that Philip made in the chat, which may not be immediately visible to everybody here. He said he wanted to point out that IDEs do not play nicely with generated code, especially when it's impossible to generate. So like the IDE is configured for a different architecture than the one that it's running on or something like that, right? Table gen in LLVM is an example of that. Trying to see through that stuff in an IDE is almost impossible.
Yeah, the problem is I don't, like right now, at least without like a lot of thought, I don't see a way of satisfying all of these requirements without having some additional like DSL layer or some tooling on top that manages something.
Yeah, some of it I think
current
comes
C++
down to
features, like there's not much you could do, right? So
some of it does come down to the techniques that you choose for doing it, right? So like the x86 code generator, the way that that's written with macros. Now, I'm not saying macros are the way to solve every problem in the world, far from it, but the way that that one is done, if you have the right if-defs in your IDE environment, it does work, right? You do get to see the enum and everything because the IDE preprocessor is able to see the expansion, right? Whereas if you have an opaque Python script, for example, that requires some bespoke process to run it, then that's less transparent, right? You know, maybe you can run it and generate a file, and then you can include that file, and you only have to regenerate it under certain circumstances, and blah blah blah. But then, you know, you still have that issue.
yeah, because the other thing that I mean, speaking of if-defs and what is currently there, there could be a completely different route of just support tools for different consistency checks and trying to avoid some of the problems that have been discussed. Some of them cannot, like things like the varying constructors and so on. That's nothing the tool will help with. I mean, you could have if that's there too, but that will look really ugly. But that could be one way. It's just like tool support on top of what's there. So, I mean, in the Linux kernel, they do everything with if-defs, really. Actually, part of my work for my PhD was coming up with consistency checks, because there they have to like make sure what's in the build script is consistent with what's in the configuration files, with also what's in the code. So we build tools to do consistency checks for that. So that's one pragmatic way of saying, you know, if this can't be solved with a clean design, is let's at least build tools that help avoid the current problems or warn developers about them.
Yeah, no, I agree. It's a very complex space to try and work in. I think it was just the point was being raised on the chat, so I just wanted to mention it. And that I certainly agree that tooling off to the side to facilitate checks and things like that is very helpful. I mean, people complain about the self in the current linter, but it is actually preventing problems if certain things are extended. If you don't have those selves, it just won't work, right? It's just we don't expect some of those things to ever be extended, but the current model allows it, right?
And the other thing about the selves, though, is that they are, the reason that they're so ubiquitous throughout the code is because anything can be extended.
Yes,
so
exactly.
If we actually if we did have a much more limited set of extension points, and the linter could figure that out, then obviously the selves would be significantly reduced.
Yeah, I guess I'm saying off to the side tooling to help enforce things, I'm completely cool with. Like, that's awesome, especially when we can run them as part of the checks and things on pull requests. I think that the only comment here is just that the more tooling that's involved in actually generating the code, the harder it may be to satisfy the requirement around IDEs and ease of comprehension, because you may not have the source to be able to feed into this thing to find the defs and that kind of stuff.
Yeah, I think the comprehension part, because if it's all like if-def based, then you also need a tool to show you what it is for your current architecture, right? So like you process things. So comprehension isn't solved by that. So.
Yeah. No.
Yeah.
Agreed.
Yeah. Okay.
Any more comments or questions for Sarah? No? Okay. All right. Well, thank you, Dr. Nadi, for taking us through this.
Yeah, no, thanks for the discussions. I think these are helpful. Try to put them in summarize some of this for myself for looking at solutions. And yeah, hopefully we have some good ideas to move forward.
Okay, great. So if there's no other questions, I guess we'll adjourn for the day then. Okay, thank you.
Okay. Thank you.